In this video, we're going to analyze one of the dangerous low-level codes, an assembly code that directly interacts with the kernel memory and This code is written in assembly for the 64-bit architecture, and it uses kernel-level registers such as GS, RAX.
In fact, this malware runs in kernel mode and has direct access to the system's critical resources.
Such code is typically used by rootkits or bootkits, whose goal is to destroy the boot structure, wipe the MBR, and corrupt critical system files.
The level of this code? It definitely falls under threat level, critical, because any device that runs this code will most likely never boot again.
An 8-byte keyword value is read from offset 0x188 within the GS segment register space and loaded into the RAX register.
In the x86 and 64 Windows kernel architecture, the GS register in kernel mode typically points to core kernel structures.
This operation is typically used to obtain a pointer to a structure that holds information related to the current thread, process, or other process-related data.
So this line retrieves the base, a kernel address that will later be dereferenced to reach the process structure or the process list.
This requires high-level kernel access. Entering this path is typically a precursor to accessing sensitive system data.
What it does, it reads another keyword value from offset 0xb8 relative to the address currently held in RAX and places the result back into RAX.
Then, it copies that value into both R15 and RBX, preserving it for later use.
This second dereference typically indicates access to a field within a kernel structure, which may be a pointer to the E process. In other words, it's the transformation of a generic pointer into one that specifically references the process structure.
The values are stored in multiple registers for subsequent access and list traversal.
Offsets may vary across operating system versions or in offline analysis, but the overall pattern, retrieving a pointer to the process structure, is consistent.